SV Math Teach back again, this time with families of functions. Now, most functions will have what is called a parent function. A parent function is going to be the simplest form of a function. And whether that's written as y equals or f of x or some other version of f of x, let's imagine we had something like x squared. That would be the simplest version of this function, right? So it would be a parabola, nice and simple. Something like this. Now, if we wanted to take that parabola and then shift it or transform it and move it essentially, we could shift it left or right, we could shift it up or down, we could reflect it across the x or y axis, we could also stretch it vertically or compress it vertically. So we'd make it look basically skinnier and taller or shorter and kind of squatter. I don't know if squatter is a word, but it would be a compression. And we could do a variety of things to that parent function. So our objective here is, well, first, I guess I left the space here, but I decided not to fill in any chart. Anybody watching this video probably has a textbook. That textbook most likely has a description of how to adjust your functions. But I have 3 examples to try to give you what you need, even if you don't have the book. So let's do these 3 examples, and that should be that for now. Now, first example says, write the equation for the transformation of the graph, y equals f of x, if we, and we're doing this one, translate 4 units left and 3 units down. Now, the truth is, in all of these 3 examples, A, B, and C, all of them are relatively straightforward. However, there is one specific thing that will cause issues. It's this idea right here. Moving something left. When I think of left, I think of like if I started at the origin, I would move left and I would end up at -4. So when I think of moving left, I tend to think of like -4. Well, that's not what this is. What we're going to say is we're going to say y equals f of x is kind of our basic idea. And then here's what we're going to do. We're going to adjust f of, and here's the key. This piece right here, 4 units left, is going to be the 4 goes here. And the symbol is opposite. So if I want to move it left, I use plus, right? So if you want to move left, you use plus, you use the opposite. Now the 3 down part, I'm just going to color code here because I have it. 3 down is just -3, right? So this would be your equation. That's what you would leave it as. This is clearly a preliminary step towards something else. So for now, that's all we need, the thing in the pink box. Let's try the second one. Letter B. Translate 5 units right, reflect across the x-axis. Okay, so check this out. We have y equals f of x. And again, I'm going to go 5. So f of x and 5. And I remember that I want to go opposite. So when I think of right, I think plus, but I need to do the opposite. So I'm going to do minus. So f of x minus 5. And then the reflect across the x-axis part. So this is kind of another piece, right? If I were to switch to pink, and if I wanted to move up 1, or I wanted to move down 2, that would be an easy adjustment. This reflection piece, let's pick a different color, is a whole new thing. Reflecting across, when we're going to reflect, we're going to throw a negative sign into the mix, but we have to put it in the right spot. If you're reflecting across the x-axis, which means if you had something on the top, it would flip over and end up on the bottom, right? Because this is your x-axis. So if you're going for that sort of movement, or you're looking at an image like that and you're trying to represent that, what you do is you put a negative sign in front of the entire function. And this is what you have. Once again, this is a preliminary step towards something better. But that's kind of where we're at on this particular topic. Now let's do one more piece. You're going to notice that these are almost exactly the same. So we have y equals f of x equals f of, and here we go, 5 units to the right. So x and 5 and negative, right? So we're going to go opposite. And then reflect across the y-axis. One more time, I'm going to go with a different color because this time we're doing reflect. So we want to introduce a negative sign, but we're going to reflect across the y-axis. So what's key here is you're only going to make the x negative, all right? And that's it. So that's the difference between reflecting across the x, reflecting across the y, and a big reminder on how you do ups and downs, that's the pink, but a more important one on the blue stuff here. When you move left or right, it goes inside the parentheses, and the plus or minus is opposite of what you would expect.